Welcome to EduRev.
Hello children, welcome to EduRev classes. I am Sarvani Nandipati, your maths educator. I have done my graduation from NIT Calicut and I have more than 3+ years of teaching experience. And in this video, we'll be starting your first chapter, Real Numbers. In case if you are not thorough with the basics, don't worry, you can actually watch the basics video before watching it. So the topics that are covered in this video are the concept of Euclid's division lemma and few problems. Let's start. Euclid's division lemma. What is lemma? A proven statement. Before going through the definition, let's look at an example. Suppose I want to find the division of 9 and 4. I am representing the number 9 with a block of 9 units and 4 with a block of 4 units. So what's my task? I want to fill as many possible units of 9 with the 4 blocks. So how many places I can fill? The first 4 places I can fill with the first 4 block unit, and the next 4 places, that is 5, 6, 7, 8, I can fill it with another block. And what happened to the last place? It is not filled with the 4th block. So if I have to put the same example in terms of division, the number of blocks, the number of the 4 unit blocks that are used is nothing but the coefficient. And the number of places in 9 or the number of units in 9 that are left not filled by 4 is called the remainder. So how could I put the same thing? I can write it as simply 9 is equal to 4 into 2 plus 1, right? 9 is the larger block that I have taken, 4 is the smaller block I have taken, 2 is the number of blocks I have used of the 4th blocks, and 1 is the number of places that is left unmapped. Now what am I doing is I am replacing the terms 9, 4, 2 and 1 with A, B, Q and R. So how can I write that as simply A is equal to BQ plus R. But here R has a condition. R value should be always greater than or equal to 0 and less than B. Why this condition came? See, in the same example, if the block was 8 units, there is no space for here. No, you will fill it with 2 blocks. So R value can be 0. I can simply write 8 is equal to 4 into 2 plus 0. So that condition is possible. So that's why R value can be equal to 0. And in that case, the first number is divisible by the second number, or the second number is the factor of the first number. And the another condition is R is less than B. Why? Say if the R value is 5 here, that means it's greater than my B, 4. Will that be possible? If I have left with 5 units, what will I do? I'll put another 4 unit block, right? And I'll tell only 1 unit is left unmapped. So always remember the R value should be greater than or equal to 0 and less than B. It's a very important condition. And when R is equal to 0, you'll simply say B is the factor of A, or A is divisible by B. This condition is very important. Just remember, any number A can be written as BQ plus R, where R should be greater than or equal to 0 and less than B. That is the thing that you have to grasp from this slide. I'm moving on to the definition part now. Given positive integers A and B, there exists a unique integer Q and R satisfying A is equal to BQ plus R, where R is greater than or equal to 0 and it is less than B. Exactly what we have got in the previous slide. And another way of representation is, if I'm dividing the number A with B and my quotient turned out to be Q. So if I multiply these two, that number I'll write it here, right? And I'll subtract it from A and say I'm getting the remainder value as R. So how can I write these terms as, like, A is nothing but the dividend, B is nothing but the divisor, and Q is nothing but the quotient, and R is nothing but the remainder. So what is the formula that you have studied during the long division? Dividend is nothing but divisor into quotient plus remainder. That is exactly what you have got, right? A is equal to B into Q plus R. So one can conclude that Euclid division lemma is nothing but the formula dividend is equal to divisor into quotient plus remainder. I hope it is clear. And why do we use that? Or where do we use that? Generally, we use Euclid division lemma to find the HCF of two numbers. Here I'll be explaining that with an example. Find HCF of 420 and 130. So I'm taking, which is the bigger among those two? 420. So I'm putting it in the place of A. And 130 I'm putting in the place of B. So 130 into 3 will give me 390. So I'm taking Q value as 3. And here it is 390. So 420 minus 390, what will be that? 30. So my remainder is 30. But how do you represent this in the Euclid division lemma form? Simply 420 is equal to 130 into 3 plus 30. Right? Now I have to continue this process again. But my divisor and the dividend gets changed. So what will be my divisor now? My divisor will be the remainder that I got. And what will be my dividend? That is nothing but the divisor in the previous step. So here 30 will be the divisor again and the 130 will be the dividend. Again we'll do the Euclid division lemma. So 30 table, how many times? 34 will be 120. So what will be the remainder in this case? Again 10. So here also you are not getting 0. That means this term, the 30 is not your HCF. But how do I represent this in the Euclid division lemma? 130 is equal to 30 into 4 plus 10 because A is equal to BQ plus R. Now what will happen? My divisor will be the remainder 10 and my dividend will be number 30, the previous divisor. So in 10 table 10 3 is 30. The remainder is 0. That means how can I represent this? 30 is equal to 10 into 3 plus 0. The remainder is equal to 0. Whenever the remainder becomes 0, whatever is the divisor that is there here, that will be your HCF. The HCF of 420 and 130 is 10. So just remember this process when they give two numbers. First, apply the Euclid division lemma. Whatever is the remainder that you are going to get, take that. If it is 0, your divisor will be the HCF. If it is not 0, the remainder is going to be your divisor and the previous divisor is going to be your dividend. And you will be applying this process continuously till the remainder is 0. Whenever the remainder is 0, whatever is the divisor that you have, that will be the HCF. So why is this process working? Because the HCF of the numbers 10 and 30 is same as the HCF of the numbers 30 and 130 and the HCF of the numbers 130 and 420. It's a very important concept. And one more thing, when you are writing in the exam, don't write this division part, okay? Just you are supposed to write only these equations. Whatever I have done here is only for your better understanding. I'm moving on to the next problem. If the HCF of 65 and 117 is expressible in the form of 65m minus 117, then the value of m is. So they are telling the HCF of 65 and 117 is equal to 65m plus m minus 117. In that case, what is m? Our approach will be, first we'll find the HCF of 65 and 117 and we'll equate to this term and we'll find the value of m. So which is the larger one? 117. So it is dividend and 65 will be my divisor. 65 twos will be 130, that's greater than 117. So I'll take only ones. 65 ones will be 65. If I subtract, what will be the value? 52. Now 52 is not the 0. The remainder is not 0 here. We have to continue the process again. Before that, how can I express this in terms of Euclid division lemma concept? 117 is equal to 65 into 1 plus 52. Now what happens? the number 52 is going to be your divisor and the number 65 is going to be your dividend. So 52 table once 52. What will be left out? 13. Again, the remainder is not 0. You have to continue the process. Before that, how can you represent that in the Euclid division lemma concept? Based on the Euclid division lemma concept, 65 is equal to 52 into 1 plus 13. Now, again I have to continue the process. What should I take now? The 13 will be your divisor and the 52 will be your dividend. So 13 fourths is 52. The remainder is 0. So here you can stop the division and the 13 is going to be your HCF. And how can I represent that? Simply 52 is equal to 13 into 4 plus 0 and 13U is your HCF. So you can simply write HCF of 52 13 is equal to HCF of 65 52 is equal to HCF of 117 65 is equal to 13. And what did they give that? The HCF of 65 and 117 is 65m minus 117. So I can replace this term with 13. So what can I write? 13 is equal to 65m minus 117. So what will be 65m? 13 plus 117. What will be that value? 130. So what will be m? 130 by 65, which is 2. So my m value is 2. So I hope it is clear. I'm moving on to the next slide. Prove that if x and y are odd integers, odd positive integers, then x square plus y square is even but not divisible by 4. These kind of questions are very important and they can come for long answer questions. And what do we know? Any odd integer, any odd positive integer can be represented in the form of 2q plus 1 where q is an integer, and all even integers can be represented in the form of 2q. So what I'm going to take is, I'm taking x is equal to 2m plus 1 and y is equal to 2n plus 1 where m and n are some integers. So I'm taking my LHS part, x square plus y square. What can I write it as? 2m plus 1 whole square plus 2n plus 1 whole square. You know already formula of a plus b whole square. What is that? A square plus b square plus 2ab. I'll be applying for this part. What will be that? 2m whole square plus 1 square plus 2 into 2m into 1. And for this, 2n whole square plus 1 square plus 2 into 2n into 1. What is 2m whole square? 4m. What is 1 square? 1. 2 into 2m into 1. 4m. 2n whole square? 4n square. 1 square will be simply 1. And 2 into 2n into 1, that is 4m. So what are these values after rearranging? 4m square plus 4n square plus 4m plus 4n and plus 1 plus 1, that I am writing it as 2. I hope it is clear till this part. And now I am grouping these elements, 4m square and 4n square. What can I take common? 4 I can take common. So it's simply 4 into m square plus n square. And again I am grouping these elements, 4m plus 4n. What can I take common? 4. So 4 into m plus n plus 2. Now from this whole thing, what can I take common? 4. So 4 into m square plus n square plus m plus n plus 2. I'll replace m square plus n square plus m plus n as another variable q. So what will this happen? X square plus y square is equal to 4q plus 2. 4q plus 2, it is an even number. Hence, it is divisible by 2. But it is not divisible by 4. Why? 4q plus 2 means it's clear that the remainder is 2 when the divisor is 4 and the quotient is q. So I can say that x square plus y square is an even number and leaves remainder 2 when it is divided by 4. Try to understand this once again. 4q plus 2, if I take common, what is that? 2 into 2q plus 1. 2 into some number will always be an even number. Hence it is divisible by 2 or it is even number. The first condition is proved. And why it is not divisible by 4? 4q plus 2. See, if I consider x square plus y square as a, so it is in the form of a is equal to 4q plus 2. Based on the Euclid division lemma, a will be your dividend, 4 will be your divisor, q is your quotient, and 2 is your remainder. So when you are dividing the given number x square plus y square with 4, you are getting a remainder 2. Whenever you are getting a remainder, that number is not divisible by the divisor. Hence, I can tell that x square plus y square is not divisible by 4. I hope it is clear. I am moving on to the next slide. So today we have completed the concept of Euclid division lemma, and also we have looked at few problems. So you can take a test after this video. In case if you want to look at this summary, you can check the notes section, and whatever tests you are going to attempt in the Edurave Infinity platform are prepared by NCERT experts. And you also get a national-wide ranking after every test you attempt, so that you can analyze yourself much more better and improve your performance. In case if you haven't taken the Edurave Infinity subscription, do it today. Thanks for staying tuned. All the best.